In this video we will continue our discussion on functions and some of their properties. Okay, but before we start talking about their properties, how about we look a little bit more on what a function is not allowed to do. Okay, so we said that, let's say if we start off with a function f defined on A with values in B. Okay, so here's the representation of the set A and here's the representation of the codomain B. And let's take a point A in the domain of the function f. Okay, once we decide that the function takes this point A into this point, let's call it f of A, all right, we cannot later on decide, oh, actually we want this function to take the same point A into another point. So this is not allowed. All right. Now, we mentioned in a previous video the fact that this is sort of a very good initial view as to what a function is, but slowly we have to move away from this because this view is just doesn't scale. All right. So let's see, for example, now if we look at a function, let's say defined on real numbers with values into the set of real numbers. All right, and let's say a colleague of yours comes to you and says, okay, here's a system of coordinates. Okay, and here's a curve, like so. All right, and they ask you, is this the graph of a function? Okay, remember that the graph of a function is the set of those points that are of the type x and f of x. All right, so that's the graph, right? So now the question is this the graph of a function? Now maybe a student that wants to check whether they understood these notions can stop the video and figure out the answer to this question. Okay, now the way I would approach this question, I would do this. Okay, I would say I'll look at this point here and draw this vertical line from this point. Okay, let's call this point A. So I would notice that this vertical line intersects this curve in 1, 2, 3 points. Actually 2 would be enough, but for the purpose of our discussion here. So this point here is on this curve. Okay, and if this curve is to be the graph of a function, okay, this point, the y-coordinate of it would be f of A, right? Because we said that points on the graph of a function are of type x and f of x. So if this is the x-coordinate of this point is A, means that this would have to be f of A. But also this point here, okay, the x-coordinate of it is A and the y-coordinate of it would be this point here. But if this curve were to be the graph of a function, this would also have to be f of A, right? So now, okay, f of A would be on one hand this, on the other hand would be this, and it would have to be the y-coordinate of this third point. So this is not allowed. So a curve like this fails to meet the requirement of a function. Okay, so because it fails what we call a vertical test. All right, so vertical test is exactly the failure that we can see on here, in the sense that we are not allowed to have two arrows going from the same point. All right, good. So this is one thing that the function is not allowed to do, and we see that given a curve, we can figure out whether it's the graph of a function or not by looking at this vertical test. Now, let's go back to functions that actually have some properties, desirable properties, and you'll see in future videos why I'm saying desirable properties. Okay, so again, let's say a function defined on A with values into B. Okay, and let's say this is our A, this is our codomain B. So we've got some points on here. Okay, let's say this point, let's call it A1. that gets mapped here into f of a1. All right, and we are going to add more information to this function. But we noticed that it could be the case that, let's say we've got a point in the codomain of this function, and maybe no arrow goes into this point. Okay, so nothing goes in here, no arrow goes in here. Okay, so when we actually noticed that in a previous video, we realized that actually it makes total sense to talk about the codomain of a function, which is b, and the range of the function. Okay, and just a reminder, range of f is the set of those b in capital B, so that there is an a in A with the property that f of A is equal to b. All right. I changed the way I wrote this definition slightly just to challenge the student a little bit, but this is one way of writing the range of f. Okay, so now a desirable property of a function would be, okay, let's call it here 1, and we say that f is onto, okay, if and only if the codomain of it, so b, is equal to range of f. All right, very simple property saying that no points in the codomain are left out, so b is equal to the range of f. Very simple, and you'll see why this is a very nice property for a function to have. All right, now if you recall our original discussion on functions, we said a function can do this. So given 2 points a1 and a2 in the domain of definition of the function, it's okay for a function to actually decide to take these 2 different points into the same point in the codomain of the function. There's nothing illegal with that. All right. Now, okay, so let's see, how do we see this from from the graph of a function? So again, let's see, if we look at the function, let's call it f from real numbers into real numbers, and let me see, okay, here's a curve. All right, let's say this is a nice curve. Okay, well, is this the graph of a function? Well, recalling this vertical test, we see that these verticals here, all of them will intersect this curve in at most one point, so this is the graph of a function. Now, here's what we can do. All right, how about we take a point here B on the y-axis? All right, and we draw this time a horizontal line. Okay, for this particular choice of B, this horizontal line will meet the graph of the function in 2 points. Okay, let's say the x-coordinate of this particular point here is a1, and the x-coordinate of this point is a2. All right, so now we've got 2 different points, a1 and a2, but because of the fact that we obtained these 2 points by drawing a horizontal line, okay, the y-coordinate of this point is b, and the y-coordinate of this point is also b. Okay, but then again we said that this is the graph of a function f, so b is actually equal on one hand with f of a1 and is equal to f of a2. Right, so actually this graph of a function has the property that 2 different points of its domain are mapped onto the same point of the codomain. So this is the diagram that corresponds to this view of a function. Okay, and now the second very important property of a function would be that f is, let's call it 1 to 1. Okay, so 1 to 1 or injective. Okay, which means a1 is equal to a2 if and only if f of a1 is equal to f of a2. Okay, and this is true for any a1 and a2 in the domain of definition of this function. Okay, so we say that f is 1 to 1 if this is what happens. All right, now this translates from this visual representation of the function by us drawing any horizontal line and not being able to intersect the graph in more than one point. All right, so again, I cannot emphasize more, especially at the beginning. Try not to stare at this sort of dry definitions or dry ways of looking at the definition of a function, but try to connect them with some visual representation. Maybe you get a better understanding at the problem or of the definition itself. All right, so this is one thing we need to remember from this video, that function is 1 to 1 if this horizontal test doesn't fail. All right, the second thing is f is onto if the codomain of f is equal to the range of f. Okay, and we need to remember the idea that given any curve, okay, we can easily test whether the curve is or not the graph of a function by looking at the vertical test.